Hello all, my name is Akash. Today we will be covering an interesting topic, how to solve an ordinary differential equation using Runge-Kutta method in Matlab. So first of all, we will understand what is fourth order Runge-Kutta method. It is the most commonly used Runge-Kutta method to solve an ordinary differential equation. The general form of RK4 is given by dy by dx is equal to f of xy, y of x0 is equal to y0. This gives the initial value of y, that is y0, and the initial value of x, that is x0. The Runge-Kutta fourth order method formula is given as y of n plus 1 is equal to yn plus 1 by 6 into bracket k1 plus 2k2 plus 2k3 plus k4. Formulas for k, k1, k2 and k4 are given separately. You can go through all of these formulas. Further, we will solve an example analytically using RK4 method. So here in this question, the ordinary differential equation is given as dy by dx is equal to into bracket 1 plus 4x multiplied by under root of y at y of 0 is equal to 1. We need to find y of 1.5, that is value of y at x is equal to 1.5. H is given as 0.5 and x is in the range of 0 to 1.5. The solution for this equation is given as we have h is equal to 0.5, that is the step size will increase by 0.5, meaning that if x1 is equal to 0, then x2 will be 0.5, x3 will be 1, x4 will be 1.5. The x1 and y1 are the initial values of x and y, whereas the xm is the value at which we have to calculate the value of y. So starting from first iteration, we have to find the values of k1, k2, k3, k4 and k. Just substitute these values of x1 and y1 provided in question in the formulas for k, and you will get the answers for k1 to k4. So after getting these values of k1 to k4, put these values in the formula of k and you will get the answer for k as 1.2470. Moving further, put these values in the formula for y2, y1 plus k. You will get the answer for y2 as 2.2470. Now for second iteration, we will follow the same procedures. Just put the values of x2 and y2 in the formula. Put all these values of k1 to k4 in the formula of k. You will get the answer for k as 3.9907. Then by using the formula of y3 is equal to y2 plus k, the answer for y3 will get 6.2377. So moving for the next iteration, that is third iteration, put the values of x3 and y3 in the formulas. Calculate k1 to k4. Again using the same procedure, calculate the value of k, which you will get as 9.7315. Using the formula y4 is equal to y3 plus k, the y4 value you will get as 15.9692. At last, the value of y at x is equal to 1.5 is found to be 15.9692. Here we have value of x4 as 1.5, so at this value of x, the value of y4 becomes 15.9692. Here we required 3 iterations because the formula of RK4 method requires the value of x3 to calculate the value of y4. So now we will move on to the MATLAB programming method. If you are watching this video and have not subscribed to our channel, we request you to subscribe to our channel. So starting with some basic commands. These are all the standard commands used to remove any previous data. Moving on to the next section. Here we will take inputs from the user. We will take the equation as an input from the user in this format, and we will assign this input to the variable named d. Further, we will take the input of step size value and assign this input to the variable name h. The initial value of x will be taken from user and assigned to the variable named a. Again, the value of x at which the y is required to be calculated is taken from user and assigned to the variable named b. The initial value of y given in question is assigned to the variable named c. In this section at line number 26, I have assigned the range of x that is given in question to the variable named x, The variable x stores the values between a and b along with a and b. The values in between a and b increase by a difference of h. To understand this command better, we will move on to the command window. So here in command window, I will write as a is equal to 10, b is equal to 20, h is equal to 2, and I will provide the above function of x in the command window. So a as 10, as 2, h as 2, and b as 20. So this gives the output as 10, 12, 14 up to 20. So now the x matrix stores the values between 10 to 20, which are increasing by the value of 2. In the next command, y of 1 is equal to c. The initial value of y that is taken from user and assigned to the variable c in previous lines of codes, as you can see here, is now assigned to the variable y as its first place value. The value of c will be stored at the first place of matrix y. Down the line to 28, this is the important part of the program. Here the equation that is inputted by the user and it's stored in the variable named d is now assigned to the variable named func, that is func. So whichever equation the user inputs in the format given as this @xy will be provided as input to the variable func. Sometimes it becomes difficult to understand this line, so you can do it like I will just do it, provide a comment here. So in this line directly you can provide a function into bracket x y and the equation that is given in question. So right now I will take it as 1 plus 4x, which is multiplied by sqrt, that is square root of y, and multiplication dot star. So by directly assigning this equation to the variable name func, you can also do it in this way directly. So these functions that we are discussing now are called as anonymous functions. This syntax must be followed to create an anonymous function, and whichever argument you provide in here, x and y we have given here, it must be included in the equation. Now moving to next section of code. Here we have used for loop to perform 3 iterations and calculate the values of k1 to k4 and k for each iteration one by one. Here for loop is used because it runs for the specified number of times and does not require any conditional statement. Here we have used the syntax of for loop. This length of x minus 1 means that the length of matrix x. This variable x which stores the values in the form of matrix, the length of that matrix will be taken here, meaning that if there are 3 elements in the matrix, the length of x will be 3, and minus to that 1, that is 2, will be the number of times this for loop will execute. So as we have studied in analytical method, the formulas for k1, k2, k3, k4 and k are now assigned to the variable name same as it is. H multiplied by f of xy we have in analytical method, which is given in code as func into bracket x of I, y of I. So when the code will start executing, the value of I will become first 1 for first iteration. This 1 value will be put in the place of I at x of 1, y of 1. Therefore in first loop, the value of x1 and y1 becomes 0 and 1 as it is given in the question. Then by putting these values in this equation of k1, which is assigned to this equation, and multiplying it by the h value, we will get the k1 value as 0.5 for the first iteration. When all the values of k1 to k4 and k are achieved but for first iteration by using the formulas, then by using the last formula of y2 is equal to y1 plus k, we can find the value of y2 by using x1 and y1. Here y of I plus 1 is written because the value of I for first iteration is 1 and we need to calculate the value of y2. So when I becomes 1, 1 plus 1 becomes y of 2. This gives the value of y2. So this for loop is executed for 3 number of times. Starting from I is equal to 1, it calculates the value of k1, k2, k3, k4 up to k and calculates y2. Again for second iteration I is equal to 2, calculates the value of y3. For third iteration I is equal to 3, calculates the value of y4. All these values of 3 iterations are stored in the variable x1 and y1. The double command used here converts the values in x into double precision. This is a simple step and mostly not required also, but I have used it for simplicity in displaying output, and also the plot command used below can take the values of x and y accurately. Now this is the last part of the program where we plot the graph of results obtained from above calculations. The x and y values up to 4 points are plotted on x-axis and y-axis of the graph. All these supporting commands, title, x limit, y label, are used to make the graph look more attractive and in detail. This is the syntax of plot command, wherein you provide the x-axis values in first place, followed by the y-axis values here. If you are watching this video and have not subscribed to our channel, we request you to subscribe to our channel. To understand the next part of the plot command, we will run the program. After running the program, the input is required in the form of equation. So you have to provide the equation that is given in question in the format that is requested. So type @x, y space and the equation that is given in question, 1 plus 4 multiplied by x multiplied by square root of sqrt y. Press enter. What is the step size h? We have 0.5. Initial value of y 0. Value of x at which y is to be calculated 1.5. Provide the initial value of y, that is 1. Press enter. So this is how the output of the program will look like, the graph, and these are the values of y which are plotted on the graph. This dash line used, you can see here in the graph, the dash line. The O symbol provided here stands for the circles given in this graph. These points that you can see, x, y, that are plotted on the graph. The B here stands for color blue. You can see the color of the line here as blue. The line width command provides the thickness of the line that is plotted on the graph. If you increase this one up to 2, 3, the thickness of this line will increase. So here we have covered the MATLAB program for solving ordinary differential equation using Runge-Kutta method. You can use this program to test different values of h, x and y as per the equation that is given in the question. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future. MATLAB is our feature. Happy MATLABing.